Good morning, dear friends. I am Dr. Linus from School of Electrical and Communication Sciences at JSPM University, Vagoli, Pune. In the last session, we have seen how one can implement this Norton's theorem in the virtual lab or virtual platform. In this session, we are going to learn how the Thevenin's theorem will be implemented in the virtual platform. There is some relation is there in between Norton's theorem and Thevenin's theorem. In the Norton's theorem, what we have done, we have shorted all the voltage source and opened the current source, and we will remove the load resistance and we measure the resistance across the particular terminal. So that resistance we have considered as Norton's resistance in the Norton's theorem. Here we will consider as Thevenin's resistance. Okay, so both the cases Thevenin's and Norton's resistance are same. Okay, then second one will be, in the previous case we have shorted the terminal across the load and we have measured the current flowing through this. So that we have considered as Norton's current. But here what we have done, we are going to do be that we are removing the load resistance and connecting the voltmeter across that, and we are measuring the voltage across the particular terminal, and that voltage is V Thevenin. So if we know V Thevenin and the Thevenin's resistance, we can calculate the load current as V Thevenin divided by R Thevenin plus RL. So in order to find out load current, what we will do, we will connect ammeter series with the load. Therefore, we will measure how much current it is. So when we calculate manually how much it will we get, accordingly the same approximately near to that we will get the values. So like that we are going to do it. So for that purpose, first we have to fix the load resistance, all those things. Already the load resistance is fixed as 100. Now I am going to fix the resistance R1 as 2 ohm and R2 6 ohm, then R3 3 ohms. Okay, so R3 3 ohms. Now what we have to do, we are shorting the voltage source, shorted 9 and 10, and connecting, there is no current source, so no need to open any current sources. Then we are connecting across, this is the open terminal, right? So we can see this is the load resistance, we already open it. Now this terminal we are going to connect across the multimeter. So what happened, once we connect this to the multimeter, we can measure how much resistance it is. Once the connection is over, there is a usual procedure, we have to check the connection. It will shows that multimeter is connected, that means the circuit is fine. So now we have to press OK. Then we can see here in this multimeter itself shows 4.5 ohm. Otherwise, that also we can tabulate it by using this add. So we can see here now R Thevenin is 4.5 and load resistance is 100 ohm. I hope this point is very clear. Then what we have to do, remove this shorted terminal of the voltage source and we are connecting the voltage source across it. Right? Now we need to measure the V Thevenin. V Thevenin, what we have to do, remove this open terminal and connect this to voltmeter. We have to connect across the voltmeter. Okay. So now these two terminals are connected to the voltmeter. Now we are measuring the voltage across these two terminal. So that voltage we will consider as V Thevenin. So let us go to the previous same procedure. We have to check with that. It is showing voltmeter is connected. Please turn on the power supply. So we have to follow the same thing. We have to be first make this power supply is on, and I am giving the maximum voltage of 50 volt. Right? Now what is the steps? Next steps we have to tabulate what is for this supply voltage of 50 volt. What is the value of the Thevenin's voltage? Right? So we are going to tabulate it. Now we can see we are getting this V Thevenin as 37.5. Now R Thevenin calculated, load resistance already fixed, and V Thevenin also we have calculated. Then what is the next steps? We have to find out load current. So load current is V Thevenin divided by R Thevenin plus RL, right? So for that what to do here, but practically how we will do, we have to remove this two connection and connect this terminal series with the ammeter, then output, then another terminal of the ammeter we are connecting to the load. This two we are shorting. So that means we are measuring the current across it. The same time the voltage is also 50 volt, right? Then we have to check the connection. It is showing load connected. Please turn on the power supply. So we have to be switch on the power supply. Now already 50 voltage we have given. Now we are going to measure those values, which values? Current, load current, we are going to tabulate it in the tabulation. So 0.36. So from this you can conclude that approximately same values of load current we got it in the Norton's theorem, 0.36. I think previously we got it 0.35. This way one can do this virtual platform, one can use the virtual platform for implementing the Thevenin's theorem. I hope this topic is very much interesting and understandable. Those who like this video, kindly like it and subscribe it and press the bell button also, so that you will get the forthcoming videos. I request all to share to your friends so that we will understand how the virtual lab is helpful in always. Wish you all the best. Thank you.